Chapter 8, Physical Optics. Physical optics is the study of light as a wave phenomenon. Some phenomena, such as interference and diffraction, can only be explained by treating light as a wave. Here, there is 6 subtopics for this topic. So here we have 3 waves propagate in the same direction, and at every point of A, B, C, D, E, F are in phase. If we draw a line joining all the adjacent waves, this line also we can call it as a wave front. This wave front is always perpendicular to the direction of wave propagation, and the length between two wavefronts is a wavelength. There is 2 types of a wavefront. The first one is plane wave, and another one is circular wavefront. So let's suppose we have the following single wavefront as shown, together with a wavelet source point. And notice now we have 5-point source of wavelet. Each of these points is essentially a source of its own individual wavelet, as shown by the following curved line. So, as shown, each particular point acts as the source that produces its own wavelets. Now, we have 5 altogether represent these 5 points. Notice if we take a line and we draw the line tangent to each individual wavelet, we will produce a new wavefront. So the new wavefront consists of a line that is tangent to all these wavelets. Same goes to circular wavefront. Huygens principle states that every point on a wavefront can be considered a source of secondary wavelet that spread out in the forward direction at the speed of the wave. Okay, suppose we have plane wavefront traveling with certain velocity and hit an obstacle with an opening width W. Assume the opening is much smaller than the wavelength of the wave itself. Here, Huygens principle can be used to explain the diffraction of wave. Each of the points in figure shown act as a secondary source of wavelet. As you can see, the tangent to the wavelet from point 2, 3, and 4 and 5 is a plane wavefront. But at the edges, point 1 and 6, the spherical wavelet going around the edge of the slit into regions it would not otherwise reach. Huygens principle suggests that in confirming the curved shape of the wavelets near the edges, the new wavefront bends or diffract around the edges, applied to all kinds of wave. One common phenomenon that exemplifies the wave properties of light is diffraction. Diffraction is the bending of light around obstacles. Huygens principle is consistent with diffraction, which is diffraction is most obvious when the gap is approximately the same size as the wavelength of the wave. Constructive interference and destructive interference. The definition of interference is the effect of interaction between two or more waves which overlaps or superpose at a point and at a particular time from the sources. The effect of interference is when the two light waves meet at a point, a bright or a dark region will be produced in accordance to the principle of superposition. The principle of superposition states that the resultant of displacement at any point is the vector sum of displacement due to the two light waves. There is two types of interference: constructive interference and destructive interference. And here we have two waves propagate in different direction and superpose or overlap. The reinforcement or resultant of amplitude of wave will produce a bright fringe or constructive interference. Destructive interference. The two waves also propagate with different direction and overlap or superpose. And as you can see, when two waves overlap each other, the resultant of the two waves will cancel off. As you can see, if I draw again, okay, the resultant will cancel off and it will produce, the resultant will produce a dark fringe or a destructive interference. Definition of coherent sources. Coherent sources means that sources emit waves of same frequency and wavelength which are always in phase with each other or have a constant phase difference between them. There is a type of coherent sources which is in phase and antiphase. Both sources start with crest or trough for in phase. For antiphase, S1 start with crest, S2 start with trough. Condition for interference of light. The first one is sources must be coherent, which means that sources emit the same frequency and wavelength and always in phase with each other or have a constant phase difference between them. Here, an example of two sources, which is the first one is laser light and the second one is LED light. As you can see, LED light is incoherent sources because of the phase is not constant. And this is another coherent light wave. And the second condition for interference light is monochromatic sources, which is the wavelength from the sources must be of single wavelength. And the last one is amplitudes of the sources that are interfering must equal or approximately equal. Path difference or delta L is defined as difference in path length of two light waves to reach a common point. It has a direct equivalent to phase difference, which is phase difference equal to 2 pi over lambda path difference. Path difference lambda corresponds to phase difference of 2 pi radian and 360 degree, which is delta L is measurement in length, phase difference is measurement in phi or degree or radian. As you can see, the path difference is also can determine how the light wave will interfere, which is constructive or destructive if they reach some common point. This diagram shows that S1, the sources of wave, also S2, the sources of wave 2 traveling to distance B. To determine the length of the sources, the length we calculate or we measured it with lambda. Let's see point S1 travel to point B. S1 to B will travel with 1 lambda, 2, 3, 4, 5, 6, and 7 lambda, which means that distance is 7 lambda. Same goes to S2, the distance between S2 to SB, the lambda is 3, 4, 5, 6, 7, 8, 9. The distance between S2 to B is 9 lambda. And then the path difference between them is constructive interference because the two lambda sources is in phase. To calculate path difference delta L, 9 lambda minus 7 lambda, we will get 2 lambda. Now to find the condition for constructive and destructive interference. We have two coherent which is in phase. Constructive interference, we will use equation delta L equal to m lambda. For destructive, we will use delta L equal to m plus half lambda. Antiphase, constructive, we will use delta L equal to m plus half lambda, while destructive interference, we will use equation delta L equal to m lambda. What is in phase? In phase means that when two sources overlap each other, whether crest to crest or trough to trough, the delta phi or the path difference or phase difference is equal to 0. And when the overlap appear bright, we will use constructive interference equation. While if the two sources overlap and then appear dark, means that we will use destructive interference equation. But antiphase, when two sources overlap and appear bright, we will use constructive interference equation. If appear dark, we will use destructive interference equation for antiphase. Antiphase means that delta phi is pi radian. Here, interference of transmitted light through double slit or Young double slit experiment. This diagram shows the schematic diagram of Young double slit experiment. A monochromatic light is placed behind a narrow slit S or single slit which act as point source. And then double slit A and B are equidistant from S. The same wave front arrive at both slits simultaneously and giving constant phase difference. Both slits act as in phase coherent source. And then the wave spread out behind each slit, interfering in the region where they are overlap, resulting in a pattern of light and dark bands on the screen. And at the center of the pattern is a bright fringe. And bright fringe is observed when constructive interference occurs and intensity is maximum. So thus dark fringe also is observed when destructive interference occurs and intensity is minimum. At the center of the interference pattern, there is central bright fringe, which is 0 order maximum, and m equal to 1 is first bright or first order maximum, m equal to 2 is second bright fringe or second order maximum, m equal to 3 third bright, and so on. But at the dark fringe, for dark fringe is m equal to 0, we call it as first dark fringe or 0th order minimum. Same goes to M1. M1 is second dark fringe but first order minimum. M2 is equal to third dark fringe and second order minimum, and so on. As you can see, M0 we call it 0 order maximum. And also we can call it as central bright fringe rather than 0 order maximum. For m equal to 1, we can call it as first bright fringe or first order maximum. For m equal to 0 dark is the same as bright fringe, but for dark, m equal to 0, we call it as first dark fringe. In order, we call it as 0th order minimum. When m is equal to 1, for fringes, we call it second dark fringe, but order we call it as first order minimum. So for bright, we will use equation ym equal to m lambda d over d. For dark, we will use ym equal to m plus half lambda d over d. Ym is distance of m from the central to bright fringe, or from the central to dark fringe for dark. That's we call it as ym. Ym for dark, from central to dark. Ym for bright, from central to bright. We will use equation ym equal to m lambda d. If we using ym equal to m half lambda, it is for dark fringe, which is from central to dark fringe. Ym is distance of m from central to bright or central to dark fringe, while capital D is distance from slit to screen. Small d here is distance from slit S1 to S2, while lambda is from the sources, and the last one m is order number, which is m0 or m equal to 1, 2, 3 and so on for bright. And for dark, also m equal to 0, but for dark fringe, 1, 2 and so on. It's all for dark fringes. There is two equation for ym, which is for bright fringe, and then another one is for dark fringe. Here, take a look for separation between two consecutive bright fringes or dark fringes, also known as fringe width or fringe separation. Refer to delta y equation equal to lambda capital D over D. Delta y is directly proportional to lambda and also directly proportional to capital D and also inversely proportional to small d. When we increasing the d, what happen is d will also increase, delta y also increase. What happen is when delta y is increasing, the fringes will be further apart. Instead, fringes between two is further apart. If we increasing the D is about move the screen further from slit. What happen if we shorter the wavelength? Shorter the lambda. When we shorten the lambda will decrease, delta y also decrease. What happened to the interference pattern? The fringes will be closer together. As you can see, the fringes between dark to dark, bright to bright is closer. And if we decreasing the D, means that the slit move closer together, delta y will increasing and the interference pattern will also be increased or be further apart. As you can see, the fringes between bright to bright, dark to dark is increased. Okay, let's move to exercise 8.1. Young double slit experiment is performed with 589 nanometer light. Okay, 589 nanometer here is lambda. Okay, wavelength. And a distance of 2 meter between the slits and the screen. Here is capital D. And then 10 interference minimum is observed. 10 minimum and then 7.26 millimeter from the central maximum, which is YM. Okay, here is YM from central maximum to 10 minimum, which is from central to dark lah ni. And then determine the spacing of the slit. Okay, given here lambda is equal to 589 nanometer, convert to meter. And then capital D, which is distance between slit and screen, is 2 meter. And then given 10th interference minimum. What is 10 interference minimum? Interference means 10 dark fringe. Okay, 10 interference means 10 dark fringe, means that M is equal to 9. Okay, interference here means dark fringe. Okay, if the question asks 10 order minimum, means that M here is equal to 10 lah. Okay, jadi from these equations, M is equal to 9 order. Okay, 9 dark fringe. Okay, let's see. What else? Okay, YM given is 7.26 millimeter. And what we want to find here is D lah, separation between two slit. Okay, here, let we draw first. D is distance between two slit. Capital D is distance between two slit and screen. We have central bright fringe here. YM is distance from central bright to 10 interference minimum. The distance between two. 10 interference minimum. Okay, which is M equal to 9. And then we know that we will use equation for dark fringe lah. Equation for dark fringe, which is YM. Okay, sebab dia kata minimum observe kan, jadi kita guna YM equal to M plus half lambda D over D. Substitute the value and you will get the value is D is equal to 1.54 millimeter. That is the answer for this question lah. Okay. Thank you.